Hello guys, welcome back to Maison African Motives. In this platform, we shall be focusing on question number 2 of the November 2016 paper. That's one of the question papers that we have been working on. So what is important is the typical questions that we actually have in this case in our mathematics N4. So we are given on question 2 that was to solve for x. Okay, so what we have is actually quadratic equation. Okay, so I'm just going to write this equation down. All right, sorry for this, guys. Sorry, very sorry for this. All right, so what I'm going to do is to write this equation down so that we can see how we can solve this. Okay, so this is question 2.1, where we are given 3x squared minus 18x plus 39 is equal to 0. Okay, so we know that from our quadratic equation, we can use the quadratic formula, factorization if possible. So it's a matter of trial and error to see which one exactly are we going to use. So what you're going to do is to divide by 3 both sides, by 3 both sides, by 3 both sides, because we can see that 3 is a common factor here. So if we are to divide by 3, this is going to be x squared minus 3 into 18, which is 6x, then 3 into 39, that is going to be 1, and 3 into 9, which is 3. So this is going to be equal to 0. So from the equation that we have in this case, which is x squared minus 6x, it's the same as this one that we had, but it's just in simplified manner. So the easiest way that you're going to do, remember your discriminant concept that you used in your mathematics N3 and so forth, even from your grade 12 mathematics, that the discriminant represents b squared minus 4ac. Okay, we know that our quadratic formula, let me take it from your quadratic formula. You are supposed to use your quadratic formula where x is equivalent to minus b plus or minus the square root of b squared minus 4ac, all right, minus 4ac all over 2a. All right, so this is the formula that we are supposed to use. But what I'm trying to explain here is you can consider the equation first so that you won't be surprised when you are solving this equation by having the discriminant, knowing that if this discriminant, which represents b squared minus 4ac, if it is less than 0, that means we are having like square root of minus 1, square root of minus 2, square root of minus 3. That's, we do not have real numbers. So these there are no real numbers, okay? No real solutions, okay? Which means the solutions that you obtain are not real. You're talking about a complex solutions in this case. So these solutions are going to be complex solutions. All right. If you are dealing with a condition where the discriminant is greater than 0, which means we are talking about a condition where this discriminant is a positive value. This part which is under the square root, this is what I'm representing here, b squared minus 4ac, this part here under the square root. Remember, you can't obtain the square root of a negative number. That is why you see this one, we are saying the roots are going to be complex. But if it is a positive, then which means you're going to obtain the real solutions in this case. So this one is, we are going to actually have real solutions or the real roots. The solutions are the roots. Okay. On a condition that this discriminant is equal to 0, that means the solutions that you're going to obtain are the same. You're having, maybe it's a 5. Okay, you're having the same solution. But the only concept that is going to change is when you're having to say we're having a 0 there. So it means you're going to have one solution which is the same. Okay, two solutions, but they're actually the same. Like it's 1 or 1. That is when you have the discriminant equal to 0. Okay, so it's best for you so that you won't be surprised if you know this concept, if you are to substitute this. Okay, anyways, let's substitute and see from our formula what you're going to have. I think I explained so that you won't be surprised. Okay, so we are going to substitute the values of a, b, and c, which is from the formula that we are given here. So this is a 1x squared. So this is your a, your b, and your c. So if you are to substitute in the formula, you're going to obtain x is equivalent to minus 6. So we are going to have minus b. So our b is minus 6, so it's minus 6, which is a positive, okay? Or you can substitute as minus, but that is going to be positive 6, plus or minus the square root of the b squared minus 4ac is this part that we have now that we are going to calculate here. So remember, we talked about the discriminant, which is b squared minus 4ac. So let's calculate our b squared minus 4ac. So b squared minus 4ac is equivalent to b, which is in this case is this part that we are having, that's negative 6 squared minus 4 times a, which is 1, times c, which is 18. All right, so we can simplify from our calculator. Let me just share the screen so that we can see the calculator here. Okay, I hope you can see the calculator now. So this is negative 6 squared. So we've got negative 6 squared, negative 4 times 1 times 18 like this. Okay, this is going to give us negative 16. All right, so we are obtaining negative 16 in this case. Okay, so okay, yeah, we actually having the exact thing. That's 4 times. Let's just try to do this, guys, so that we see if you're having exactly the same thing here. All right. That's negative 16 actually. Thinking that there is one of the values that is not exactly here. All right, we've got 3, we've got 6 here, we've got 1, 3, which is 18. Okay, so that's b squared minus 4 times 8. Okay, we can even prove this. Okay, we can even prove this using those values. Okay, so let's just prove using these actual values. This is our A, our B, our C. So you just want to prove if actually we are going to have something that you can simplify, because we know that square root of 16 is 4. So let's see what we have. It is if it is the one that we have originally, which was negative 18 squared minus 4ac. So that is going to be minus 4 times a. Our a was 3 and our c was 39 like this. Okay, so this is going to be negative 144. All right, so thus we are obtaining something which is the same. Okay, so that's it. We are going to obtain this negative 16 in this case. Okay, so that was actually the same. Okay, if you simplify that square root of negative 144, using those numbers that we have, we are going to obtain the same thing with the one that we have, this simplified one. Okay, so that's negative 16 here. So comparing negative, it tells us that this negative that we have, it's a complex solution that we are going to obtain at the end. We are going to have complex solution because it's a negative solution. Okay, so that's a negative. Okay, anyways, if you this idea, it's just for you to know this idea. It's not like it's something that is very, very important. Okay, anyways, 2 times a, your a is 1, so 2 times 1 in this case, that is 2. All right, so that's it. We have got our equation here where x is equal to the square root of a negative. From our complex numbers now, we know that the square root of negative 1 is equal to I, or you can write it as j. Okay, so in this case, you just write in either way I, or you can write it as a j. So why introducing this? Because we've got square root of negative 16, where we know that the square root of negative 16 can be written as the square root of 16 times the square root of minus 1. 16 times minus 1, that's minus 16. But we know that square root of 16, that is plus or minus 4, square root of minus 1, which is the one that we present as I or as a j. So this is going to be plus or minus 4j. Okay, so this is what you're going to obtain from the solutions. This is going to be 6 plus or minus the whole square root of minus 16 gave us plus or minus 4j. So this is our 4j in this case, or you can write it as j4, either way. Okay, everything over 2. All right, so we can separate this because we've got every fraction, the whole of this fraction over 2. So it can be x is equivalent to 6 over 2 plus or minus the square root of 4j over 2, which is going to give us something like 2 into 6, which is 3. So our x is going to be 3 plus or minus 2 into 4, which is 2j. So that's what you're going to have. So you can separate the solutions to say, therefore, our x is equivalent. Remember, it's plus or a minus. So it can be 3 plus 2j, or our x can be written as 3 minus 2j, or it can be j2. I don't know the way that is easier for you. So these are the complex solutions that we are going to have. As I said, that the solutions are going to be complex, the values. Okay, so let's see the other part of the question on 2.2. Okay, on 2.2, you're given a complex number which is in rectangular form, and we are asked on 2.21 to find z bar, the bar of z, which is the complex conjugate of z. Okay, so that's the complex conjugate of z, where we know that the complex conjugate, simply you introduce a negative on the imaginary part in place of the j. So there is a negative here. So if you introduce a negative, that's negative by negative, which is a positive. So the complex conjugate of z is going to be 3 over 10 plus a j of 30 over 6. Okay, so you can just write as it is. Yes, you know that 30 over 6 is a 5. So you can write it as j5 is fine, or you can just write as j30 like that. All right, on 2.22, calculate y and theta of z. Theta may only be positive. So given that theta is only positive, then show all the given steps. Okay, so we are asked to find y and theta. It was actually supposed to be find r and theta, that is in polar form. So this format is referred to as the polar form. Okay, whereby in polar form, z is supposed to be written as r angle of theta, or r cis theta. Z can be written as r cis theta. All right, so let me explain on this part separately, because now I'm explaining a lot here besides working on the question. Okay, so this is 2.2. So what is important on the question is that, guys, understand what you are given. They are asking you to write the polar form, whereby I said this is r here in place of y, this is r here. Okay, take note, they are saying of z, not z bar. On 2.21, we are asked to find z bar, which is the complex conjugate. Okay, that is the complex conjugate of z. But this part, they are asking to calculate r and theta of z, which means we are going back to the original z, this one that we had. Okay, so that's the first thing, to write the z that we had before. Okay, so our z is given as 3 over 10 minus j30. Then we write that in polar form from rectangular form. Okay, so let's have our z here, where we are given z is equivalent to 3 over 10 minus j30 over 6, of which you can write this as 3 over 10, that is 0.3. So this can be written as 0.3 minus j 6 into 30, that is going to be 5. Okay, so remember, for you to convert in polar form, where I say that in polar form, z is given as r angle of theta, or z can be given as r cis theta. All right, where are we here? How are we going to have the value of r? How are we going to have the value of theta? How are we going to have these values? Okay, the first thing is for you to represent this on an Argand diagram, which is the easiest way for you to know how to find the r and how to find the theta. Remember, on the Argand diagram, guys, I actually explained before that Argand diagram is given the horizontal axis is the real axis. Okay, so this is the real axis, and the vertical is the imaginary axis. Okay, so this is where we have got this is how you represent it. Okay, so as you can see, according to our z in this case, 0.3 is the real part. This is the real part, and this is the complex part, which is the imaginary part. Okay, so the complex part is the imaginary part. So according to the real part, our Z is at 0,3, which is positive. So you can, it's a sketch that you're doing. Okay, so this is at 0,3. All right. Then the same Z on the imaginary part, it's at minus J5, which means you can just have your minus J5 like this. So it is going to fall into the fourth quadrant, and each diagram is represented from the origin in this manner. Okay, so that's it from the origin. So what you need is the quadrant, which is the fourth quadrant, and it simply indicates that for here we've got 0,3, okay, up to this point here, they will meet. So from this point to this point, that's the minus J5, which means we are simply indicating that this is minus 5. From this point to this point, that's 0,3, which means we are simply indicating that this is 0,3. So the R they are talking about is the resultant that you calculate from this point, where our R can be given from the formula, which is the square root of a squared plus b squared. So the a and the b are the numbers, that is the real part and the imaginary part. All right, so this is the angle theta. So you're supposed to calculate R, then you calculate theta. So I just explained like what you're supposed to have actually. Yes, you can do shortcuts, it's fine, but that's the exact thing that you're supposed to have. So our R in this case is the square root of a squared plus b squared from our Pythagoras theorem, which is the square root of 0,3 squared plus negative 5 squared, or you can just write it as 5 squared. Even though you write this, you can simply, you're going to have the same answer. Okay, so let's just share back that screen so that we can use our calculator properly here. All right, so from our calculator, just square root direct. This is 0,3 squared plus negative 5 squared of just 5 squared direct. Okay, so this is negative 5 squared, which is 5,0 and so on and so on, 5,0 and so on. So 9 is going to change this 8 into 9, so it's going to be 5,009. All right, so we move on to theta, which is the angle that is between, as you can see from the side that we have, we've got the opposite according to theta. Negative 5 is the opposite, and this 0,3 is adjacent. Okay, so that means the only ratio is for tan from our soccer tower. So this is our soccer tower. Okay, so tan, which is opposite over adjacent. That's why this formula can be written in other ways as theta is equivalent to arctan, the opposite over the adjacent, of which the opposite is b, the adjacent is a. So it's going to be arctan b over a. But this is not the exact theta that you're going to have. This is the theta from this point, which is from inside the quadrilateral. So it depends now with the question how this theta can be expressed. Can it be expressed as a negative? Can it be expressed as a positive? That is what actually matters the most. Okay. Anyways, let's calculate our theta. So theta is going to be arctan, the opposite, which is negative 5 over the adjacent. So it's here tan theta is equal to opposite of adjacent. So to find theta, that's why we are saying arctan, opposite of adjacent. So opposite, negative 5, adjacent, which is 0,3. All right, so let's calculate our theta. Make sure that your calculator is in degrees. So that theta arctan, okay, let's put this way. So it simply means arctan, that's shift tan, negative 5 divided by 0,3. So this is 0,3, or you just put the normal division, is fine. That's you're going to obtain negative 86 and so forth. Okay, so the negative 86 that we are seeing here, okay, let's just write off to 3 decimal place, which is negative 86,556. Okay, so we've got negative 86,556. 5, and we've got a 6 like that. Okay, so what is important, guys, is that the theta that we have here, the negative that we are talking about, is because we are dealing with tan. And truly, tan is actually a negative here because we have got all students take calculus. So in this quadrant, this is the quadrant for cos. So if you calculate the angle for tan, it will be a negative. But this angle is this angle that we see here. This is the theta that we have, which is actually 86,556 degrees. And also from the direction, we are taking from this direction, which is a negative. Okay. But remember, we are given that our theta now, okay, let's get back to the condition of the question so that we all understand. We are given that the theta that you are going to have here, theta may only be positive. All right, so if theta can be positive, remember how you take your angles, guys. This part you must know it very, very well, that from the angles that you have, if you take the angles in the clockwise direction, they will be negative. If you take these angles in the anti-clockwise direction, these angles will be positive. So that's why you see this angle is negative, because we are taking it in the anti-clockwise. In the clockwise, I mean. So if I'm to take it in the other way, that is the anti-clockwise direction, okay, let's represent this in the anti-clockwise direction like this. That means we are going to have the same angle, angles taken from the same point, okay? If you take angles from the same point like this, if you take angle from this point to this point, let's say this is the angle that you have taken. If you take from the same point, but in another direction, like from this point, but now going this direction, these two angles will be equal. Let's say this is alpha, this is beta. These two angles are this, they perform the same function, like they are actually equal. So when I'm saying these two angles are equal, okay, if I'm saying this alpha is equal to beta, I'm not saying the exact value they are actually, no. They are equal, but they are different angles. So they are equal in which sense now? They are equal in this manner to say that if you are to find the sine of alpha, it is the same value that you're going to obtain when you are finding the sine of beta. That one you obtain, even if you are to use tan, if you find the tan of alpha is the same as the tan of beta, that is to show that these two angles are equal. So this is the same concept that is happening here. This angle of minus 86,556 is the same as the positive angle that we are going to take from the same point here, but now going in the anti-clockwise, which is the whole of this angle. So how can you find, or how can you determine this other remaining angle, knowing that angles are at a point or a complete revolution, they add up to 360 degrees. So we are going to just subtract this angle from 360 degrees, okay? So therefore, our theta is going to be 360 degrees minus the 86,556, which was taken in the clockwise direction, which gives us a negative value. So this is going to be a positive value, which is the same as that answer that we had before. So 360 minus 86,556 like this, we are going to obtain 273,443. So it's because of the rounding of the concept. So it's 273,444 degrees. Okay, so that's what you're going to have at the end. All right, so this is the theta, which is a positive. Now, this one was a negative. So remember now we asked, okay, let's get back to the question before we talk something else. The question was calculate y, r, and theta. We are calculating the value of r and the value of only the value of r. So it's not like you're going to write your answer as in polar form. But if it was to write your answer in polar form, these are the answers actually that you're having. Let me explain this way so that we understand. I'm saying these are the values. The value of r is equal to 5,099, 5,009, and this value of theta, which is 273,444. These are the values that you are being asked to calculate. But if the question was now write in polar form, you're going to write your z now. Remember, I told you in polar form, z is equal to r angle of theta, or it can be written as r cis theta. So writing in either way, z was going to be equal to r, which is 5,009, angle of theta, which is 273,444 degrees, or you can write it as 5,009 cis theta, which is 273,444 degrees. So I'm just saying this because sometimes they might ask you to write in polar form. Okay, it's not like the question is ask, calculate R. No. Sometimes they might ask you to write in polar form. This is the polar form. That's how you write your answer in polar form. Okay, anyways, let's continue to the other part of the question that is on 2.23. Now on 2.23, we are now asked to indicate all values calculated in 2.22 on the Argand diagram. Okay, already we have drawn the Argand diagram, but this was the Argand diagram that we had when it was in rectangular form, which is the Cartesian form. So we're going to have the same diagram, but representing these values which are in polar form, the ones that we calculated. Okay, so it's just the same diagram, but now we are writing the values that we obtained, which are in polar form. So this was 2.23. So remember our diagram was like this, guys. It's not going to change anything. Okay, so this was the real axis, and this is actually the imaginary. Okay, we had a line which was drawn from this point with a line like this. So our line was drawn in the fourth quadrant like this. Okay, so what you do is that if you are representing in polar form, because they are saying from the answers that you obtained, which were in polar form on 2.22. So we are going to see that our R in this case is 5,009. Okay, 5,009. This is where our R lies. So you just represent our R at this point to say our R in this case. Okay, let's just write something that is visible. Our R is equal to 5,009. Okay, then our theta, you represent the theta now, not this angle here, but the other one, which is on the other side. That is where your theta is. Remember, that was the positive theta that we are asked to use on the diagram. So you indicate the angle theta, where our theta in this case is 273,444 degrees. Okay, so that's how you represent in polar form. Okay, so we've got real and imaginary, or you can write anyway that is the one that you are used to, but that is what we have. Okay, so let's check the other part of the question now. So let's see here the other part. Okay, this is up here. On 2.3, okay, this was actually 3 marks, 3 marks. Okay, 2.3, fully factorize the following. Okay, so there we are asked to factorize the following expression. Okay, let's see the expression that we are given. That is question 2.3. We are given 2x plus 5y to the exponent of 3 minus x, all right, minus 3y like this to the exponent of 3. Okay, so this is one of the most asked questions in your syllabus, guys. They are testing you actually here. Do you know how to factorize cubic expressions? Okay, they are these two most important. I can just say these are identities of factorization. Okay, if you are given something of this nature, that's a cubed plus b cubed like this, you are going to obtain a plus b into a squared minus ab plus b squared. Okay, if it is a cubed minus b cubed like this, it is going to give you a minus b into a squared plus ab plus b squared. So as you can see, they are just the same. If it is a plus b, they're a plus b. Okay, a minus b, then here it interchanges the signs that we had. So this is the part that they are actually testing you to say, do you understand these identities on your factorization? So if you have to say this is 2x plus 5y to the exponent of 3 minus x minus 3 to the exponent of 3, which is the same as a cubed minus b cubed. So you're going to represent that this is your a. So this is your a and this is your b. So if this is my a and this is my b, therefore I can factorize this expression that we are given here to say from this whole expression that we have, our part is going to be a minus b. So we say this is a and this is b. So our a in this case is going to be 2x plus 5y like this. Then we subtract b. So it's best for us to write this in a bracket because b is also an expression. So we subtract b, which is x minus 3y like that. Okay, so this is the part of what? Of a minus b. Then we move on to a squared plus this part. So let's start with a squared. A, which is the a here, which you said is 2x plus 5y. So it is going to be in another bracket. We are going to have 2x plus 5y like this to the exponent of 2 plus AB. So AB means A times B. A times B. So it's going to be plus A, which is 2x plus 5y like this, times B, our B, which is going to be x minus 3y like this. Okay, so that's plus A times B plus b squared. So this is going to be plus b, which is x minus 3y squared, like that. That is your b squared. So this is what you have here. All right. So it's best for you to know your factorization and also to know how to expand a quadratic expression when raised to the exponent of 3 like this. Remember that if you have got if you are given a plus b to the exponent of 2 like this. This one, it gives us a squared plus 2ab plus b squared, okay? If it is a minus b squared, it is going to give us a squared minus 2ab plus b squared, okay? And also just this one, just for interest's sake, a squared minus b squared, don't confuse this one, it's a difference of two squares. When you factorize it, it gives you a plus b into a minus b. So these one, they are very, very important in your syllabus to know them. And if you know this, it is going to be very, very easier for you. Okay, so anyways, let's apply the concept that we have now. The first part of the question here is for you to expand brackets and collect like terms. Okay, so that's it. We're supposed to expand the given brackets, then we collect the like terms, or we can just leave it like that. Guys, to expand it there, this is going to be too much. For 3 marks, okay, for 3 marks, guys, let's just leave it at this point because it's going to be something else. Okay, let's just leave it there. Okay, but if we are to expand, that's another way. Okay, that's another way. If you are to expand, it's good. But if it was maybe a lot of marks, okay, let's just expand. But I'm saying our answer is fine at this moment. Okay, let me just say here, our answer is fine. But let's just expand for interest sake. If we were to expand, this was going to be 2x minus x here. Okay, this is a minus, which is plus 3y like that. So you're going to collect like terms, which is 2x minus x, that's x, 5y plus 3y, which is 8y like this in one bracket, into this part 2x plus 5y squared. So you're going to apply this identity a plus b squared, which is a squared. So this is your a and this is your b. All right. So a squared, that is 2x squared, which is going to be 4x squared plus 2ab, which is our a, is going to be 2 times a, which is 2x times b, which is 5y like this. So 2 times 2, that's 4 times, which is 20xy. So we're going to have 20xy. Okay, we are done on expanding this. We move on to this part, we expand again. So this is going to be 2x times x, which is going to be 2x squared. Then we've got a 2x times minus 3y, which is minus 6xy. 5y times x, which is going to be plus 5xy. 5y times minus 5, which is minus 3, which is minus 15y squared. That's y times y there. Okay. Then whatever that we have, we add. So if we're adding, just write as it is x minus y squared. That's a minus b. Okay, so this is your a, this is your b. So as you can see, it's going to be a squared. Okay, so from our a squared, okay, I'm just looking for something here. Okay, we forgot to add the b squared here on this one, b squared. Okay, so this was supposed to be plus b squared, which is 5 squared, which is 25y squared. I can see it now from this one. Okay, anyways, so here we are going to have a squared, which is x squared. So this is going to be plus x squared minus 2ab. So that's minus 2 times a, which is x, times b, which is minus 3y. Okay, oh, okay, our b is 3y because the sign is already there. So it's going to be 3y like this. So negative 2 times 3, that's negative 6. So you're going to have negative 6xy. And the last part is plus b squared, which is our b is 3y. So 3y squared, 3 squared, that's 9x squared. Okay, so this is what you're going to have here. So at the end, you're going to have 8x plus 8y into, we can collect like terms here. This is the same as we've got 4x squared plus 2x squared here, plus 1x squared and 9. So we just have to add those numbers together. So if we add these numbers, we've got 4 plus 2. All right, then here we've got plus 1. Then on this one, we've got plus 9. All these numbers, they're 18 plus 9, which is 16. So we are going to obtain 16 here, 16x squared. We move on to xy. So you can see that is xy. You've got xy on this point. You've got xy at this point, xy at this point, xy at this point. So you add, you combine those together. That's 20. You move on to minus 6, which is minus 6. You move on to plus 5xy, which is plus 5. You move on to minus 6xy like that. So this is going to be positive 18. So we are going to obtain positive 13xy like that. Okay, we move on to y squared. So as you can see, there is also y squared, the one that we added here. Okay, and also we've got y squared here. Okay, so these are the two, 25 minus 15 is that. So yeah, that's 25 minus 15 in this case, which is 10. So you're going to obtain positive 10y squared, okay, in a bracket. So can we factorize this? Actually, no, you can't. So just leave it like that. But if you can factorize, that means we have to factorize again and so forth. But I'm just saying this is for interest sake. Our answer is already at this point here. But let's say you wanted to expand and see how it's going to look like at the end. This is how it was going to look like at the end. All right, so that was question 2.3, where we are given a condition to factorize a cubic expression. Let's check the other part that we have on question 2.4, which is actually 4 marks. We're given to make A the subject of the formula, which is one of the other most important part that we have in our syllabus to make the subject. So we're given P plus the cosine of x is equivalent to t e to the exponent of at sine of x, and we are given to make a to be the subject of the formula. Okay, it's true you are dealing with a complex solution. Yes, it's true. You are dealing with an exponential part, which is having a here in this case, where you need to introduce ln to work with e. But there are some other parts that we have which are affected, which can be removed from that e that we have. Okay, which part are we talking about? We can talk. Okay, let's start by the question. Let's just have our question back here. Sorry, let's have our question back. We are asked to make a to be the subject. Okay, so that's a here. So which means t and sine x, these two, they have nothing to do with the a. So we can divide by t both sides and sine of x. If we are to divide by these both sides, t sine of x, that means t and t will cancel, sine and sine will cancel. We remain with e to the exponent of at, which is equal to the whole of this expression, which is p plus the cosine of x, everything over t, the sine of x. That's it. So as we can see, on E, we are now left with a single term. There is a single term. So it enables us now to introduce ln without any excuse. The major reason of introducing ln is because we are having E. So it's best to introduce ln there. If it was any other letter or any other number, then you can introduce log, it's fine. But this one, please introduce ln. I want you to see what is going to happen. So ln both sides, okay? Ln works the same way as the log. If there is an exponent, like I always say, if you are given p, the logarithm of m, this one gives us the logarithm of m to the exponent of t. That means any exponent can be raised to any number that is multiplying a log can be raised to be an exponent. If it is an exponent like this, we are going to drop the same exponent, which is p log m. That is what that we say, p log of m. So here we are supposed to drop the exponent, which is at. So we are going to have at ln of e, okay, which is equivalent to the ln of this whole expression, which is p plus the cosine of x over t, the sine of x, like this. Okay. So from this part, it's very, very important for you now to understand the concept because of the introduction of ln. We know that ln e is equal to 1. So if ln e in this case is equal to 1, you are left with at, which is equal to this bracket, and you want to make a to be the subject. So what are you going to do? Definitely you divide by t both sides. So therefore, our a, if you divide by t, is going to give us something like a is equivalent to the whole bracket of this, the ln of p, okay, the ln of p plus cosine of x over t, the sine of x, like this, everything over t, the one that you used to divide. So that's what you're going to have as a as the subject of. So these are very, very important typical questions, guys, to work with. I encourage you to work as much questions as possible. Okay, so let's check the other part of the question. That was question 2.5. Okay, question 2.5. Let's see what we are given. Let me just remove here. So in question 2.5, we are given to solve for y if 5 to the exponent of 2y plus 2 is equal to 3 to the exponent of 5y minus 1. Okay, so that's 2.5. So let's see. So on 2.5, that's 5 to the exponent of 2y plus 2 is equivalent to 3 to the exponent of 5y minus 1. So there are so many ways that you can use, but it's easier or it's best for you to introduce the logarithm at once, or you can introduce ln. So you choose which one is best to introduce the log or to introduce the ln. Okay, so in this case, since we introduced ln in that question, let us just continue with that ln. Okay, so if we introduce ln here, we are going to drop the exponent, just like what we did from that previous question. You drop the exponents. So that means this can be written as the 2y plus 2 multiplied by ln 5. So this is going to be ln 5, which cannot be simplified like ln e. It's a special log that we have, which is equal to 1. Okay, you do the same here. We drop the exponent. This is going to be 5y minus 1 into ln 3. Okay, since we are supposed to calculate the value of y because you're solving for y, you can expand the brackets, or you can find the value of ln 5, you work with it. You find the value of ln 3, you work with it. But for me, it's best to keep these logarithms as they are, the ln as it is. Okay, what am I trying to say? Solve with the ln, just expand bracket ln 5 times 2 times 2y, that is going to be 2y ln of 5 plus 2 times ln 5, which is going to be 2 ln 5 is equivalent to, you do the same here, that's 5y times ln 3, which is going to be 5y ln of 3 minus 1 times ln 3, which is minus ln 3. Okay, so for you to find the value of y, you're going to collect the terms with y to one side of the equation, avoiding to work with negative. So it's best for us to leave 2 ln 5 and we transpose ln minus ln 3 to this side so that it can be a positive. So this is going to be 2 ln of 5 plus the ln of 3, which is equal to, so definitely on the right hand side, you are remaining with 5y ln 3. So if you transpose 2y ln 5 to this side, it's going to be a negative. So that's negative 2y ln 5. Okay, you want to calculate the value of y. So on the right hand side, you can see there is y on this part and another y on the other part. So you can factor out this y that we see here. All right, so if we factor out y, we are going to remain with 5 ln of 3 minus, if you factor out y here, this is going to be 2 ln of 5. But this whole part is equivalent to ln 5 plus ln 3. Okay, so to find y, definitely you have to divide both sides by the ln, which is affecting y here. So therefore, y is equivalent to 2 ln 5. So that's 2 ln 5 plus ln 3. Everything over this expression that you have divided with, which is 5 ln of 3 minus 2 ln of 5. Okay, so that's what you have, and you can just use your calculator now to simplify this. Having a fraction, that's 2 ln 5 plus ln 3. Okay, so this is ln 3. Everything over 5 ln 3. Okay, so this is going to be 5 ln 3 minus 2 ln 5. Okay, like this. So you're going to obtain 1,898. Okay, so this is 1,898. Okay, to 3 decimal places. 4 cannot change 8, so that's why it remains like that. Okay, so that's the value of y that you're going to have, or that you're going to obtain after solving this typical equation. So you just have to revise as much questions as we can, guys, for Meson African motives, and also from your textbooks, the ones that you're having, and question papers. Let's try to revise as much as we can, preparing ourselves for the exams which are actually ahead of time. So that was question 2. All right. Let's revise as much as we can. From Meson African motives, till we meet again.